Another question that's medium or hard. I feel like hard is always gonna be like, I feel like hard is always going to be, okay, this is quite standard BFS. I'll do it for a warm up. I'll probably not part of the .45 minutes. And so if grid ij is 1, then answer plus equals 1, and then q dot append I comma j, and then c dot add I comma j, and while q node equals q dot pop 0, and then for nade So this is just a visited check, and then these are just bound check, so it's in bounds, new row and new column more than 0, new row less than the number of rows, and new column less than the number of columns. Then, and only if it's 1, right? Then q dot append, and then next iteration will pop it. Yeah. In next iteration, we'll hit this again, and no, actually. Yeah, we'll add this, and then here we'll just keep doing BFS across all ones via this bound condition and scene check to avoid infinite loops. And then when we finish exhausting this queue, then we have looked at an entire island. And then an ij not in scene. So for example, this first hit we'll explore the entire island. The next time around we see this, it'll already be in scene, so we just output 1, this will do this, and then mark these as seen, and then it'll just loop through here, and then it'll find this one, and it'll pop and mark it as seen. This is seen, and then these are not ones, or yeah, these are not ones, so it won't add anything. And then yeah, return answer. Oh, and I need to define directions, of course. Infinite loop, but I pop. So for some given node, I'll scan our directions with the new row and new column. Print. But scene is, we never add scene, like what's going on, like we also pop, so why is while queue always? Oh. Damn. Okay, let's do for realsies and design a structure that constraints of an LRU cache key if key exists. Otherwise, add the key value pair to cache if the number of keys exceed the capacity of from this operation evict the least recently used key. Okay. And then self dot capacity, and then self dot what if we try to get stuff that hasn't been put in? So, I don't know, like, oh, okay, not found. So I can just say mem equals -1 times capacity. And then so if I want to get something and go ahead and just return self.mem of key. If I put something, then I don't return anything. But my self.used keys should append a key, and then also if length of self.used keys is greater than capacity, so let's say capacity is 5 and the length is 6, go ahead and just pop the 0 or the left-hand most element, which is going to be the least recently used one, and so then this handles the LRU portion of it. Oh, actually this is insufficient. So I see, that's the tricky part. Well, let's do the easy part first, which is saying that self.mem of key is going to be of some value. That's easy. We append this key only if it's not in. So if it is in there, adding a new key is the only way we would actually have the length of the keys exceed our capacity. Otherwise, there's no reason the size of this would grow. If it is in self.used keys, then I need to find out. So for example, right, let's say 2 is now a key I want to use. I need to convert this to 34072 because then this is most recently used. And in this case, if we have a hit, so if key in self.used keys, we won't ever add a new one, which means that the array must always be unique. Put must be O of 1 average time complexity. Getting it also updates key. So if is there a data structure to okay, so key 1 and key 2 and get key 1. So LRU was 2 evicts 2. So the get does update the recently used key. All right, so the same thing as here. In an O of 1 fashion, so you could use a set, but a set isn't ordered. And if you use a list is ordered, but the lookup's O of n, the lookup is O1, but it's not ordered, so you don't know what the least and most recently used are, right? Not sure. What? Oh, element in this icon. Dot index. I mean, functionally, I guess I'm not worried about performance, I'm more worried about functionality for now. So to review, this is my stack of keys. This is the initialized memory to -1 such that if things haven't been written yet, then you have that, and then set up the capacity, it's just the capacity of this RU cache object. If I'm getting a key, then because if key isn't in used keys, there's no, it is technically the most recently used key, but it's also not a key that you'd ever evict, so it doesn't matter. So key index is just going to be finding the index of this key, if it is in it, and it self.used keys equals this rearrangement where it's just basically going up to but excluding the key plus the index object key rest array plus the arrayized key index of the used key, and yeah. So this pattern is also done here. Oh, okay. Self.mem is a default dict of a none. And so if this key doesn't exist, then return -1, else return the key. And then if I put stuff in, then this is simply just saying add a value to the memory. Huh? This is the same. Key value, and then get 1. So you have this at the end of this, and it's not greater than self.capacity, so nothing's deleted. And then on my get, and then also we would have 1, 0, and 2, 2. And then get of 1 would say, is 1 in this? It is. So self dot used keys equals 0 to 0, which is nothing, plus this, and then plus, so 2 to 1, basically. I'm not sure what's happening. So the first time we output -1, but if I do get 1, then why is it none? Like if I get 1, then I'll just do it simpler, I guess, if key in self.mem. Yeah, I think somehow this syntax is weird. Return -1 if not. Oh, because 0 is also, it's not just none. Yeah. So actually, if the value 0 is also tricky. Okay. Okay, so let's not even bother double linked list. Why does a linked list work? Okay, so this is a linked list node with key and value, and prev is none and next is none. So it's a doubly linked list. Capacity is capacity. Wish this was named a lot better. Self.head.next is self.tail. Okay, sure. You just have two nodes pointing at each other. So if I go ahead and put this is not shorter actually. So if I set, then if key is in the dict, then self dot remove self dot dict key. Self dot dict key is n, and self dot add n. Okay, so this is actually creating two dictionaries that link to each other. Self.connect. So maybe I can just start with the high level. Put if key is in self.cache, self.delete the key, and then self.append the key and value. So this, I guess, is just overwriting it. So what does this delete do? This delete says, I want to connect I want to look at this before and next dictionary. So something's before this key, something after this key, and I want to connect it. So I see. I want to connect. Actually, this is two lookups, so it's extremely confusing. Self not before key. So whatever was before this key I'm trying to delete is A, and A's next thing will be B, which is okay. I see. So basically, it's kind of removing. So before it was before key and then next key is like this, and then the key and then next of the key. This is saying, well, without this key anymore, then whatever was previous must connect to this key's next thing. And likewise, whatever was next there before is going to be the one before the current key. So it's just basically making it so that the key is going to go missing. I feel like this connect should be called delete because you're deleting the key. I guess the way you call it matters. Anyway, so then you update the table so that you pop the key and then delete the before of so you delete the data and then you also do the cleanup on the table because there's no key anymore. It doesn't exist, so there's no before or next for it. Okay. And then otherwise you append. Append is saying what? Self.cache equals k equals v, and then you connect self.before, comma, self dot before of the tail comma k. Self dot connect k comma self dot tail. I see, because you put it in, then this is always just before the tail, which is the very most recent element, and then you want to connect the k to self dot before, self dot tail. So self dot before, self dot tail, self dot before, self dot tail dot next, self dot next of self dot before, self dot tail. So self dot next of self dot before's self dot tail is k. And self dot before of k is self dot before self dot tail. So this says delete the most recently used. I guess I don't get these two lines. This is straightforward. Val equals self dot cache key, and return val. That's straightforward. Self dot delete key and then self dot append. Self dot delete means remove it, and then self dot append means I'm the most recently used. This also means I'm most recently used. So append is really like back to these two lines. Why connect it in this way? What does self dot tail dictate? Self dot tail dictates I guess before self dot tail dictates your last element, and then self dot nexts. So whatever next is next of head dictates your first element. Okay, cool. But then what's with the connect? So I get how like k connects to so k is b. So imagine before this call, before self.tail, there's like some newest element. So this is just saying that, well, Q is a new key in town. So self.before K is now going to be pointing to the previously newest one. So now A is like the second newest one. So this is what this is saying. And then the next of the second newest one is going to be B, which is K. Okay, so I get that. Then, and then connect K to tail. So this is saying that the tail, so before the tail is K, and then next of the K is tail. Okay, so then I got that. What's this ordered dict stuff? Self.size is cap, and if I am getting it, return -1 if not in the cache, otherwise this. Self.cache.move to end key. Oh, because if we pass this, we mean that the key is existing. And if the key is existing, then the val, yeah, then we must have a val, we return the val, and then before we return the val, we shift the key to the end, which is the most recently used. And then here is the same thing. If the key is in the cache, we want to delete it, and then why do we want to delete it? Self.cache pop item last equals false. So I guess this pops the first item, and then this makes the cache key equals val. But why? Oh, I guess this is just, I guess you could also do self.cache move to end and then do this. But I guess if you delete this and then assign this, then it's the same effect as moving it to end. Ordered dict seems cool. The pairs are returned in LIFO order if last is true. In FIFO order, if it's false because it's least recently used and the oldest one gets deleted, then we're doing FIFO. So first in, first out means last in, last out. Sorry. First in, first out means the oldest gets popped, which is, yeah, last is false. And moving existing to the end of the order dictionary, the item is moved to the right end if last is true. Or the beginning of last is false. Yeah, last is true. Yeah, I didn't know about ordered dict. A lot of these collections are actually quite useful for these problems, so I feel like in an interview they would make you do this. Okay, cool. Let's see if there's another one. Given a root of binary tree, return the zigzag level order traversal of its nodes, i.e. left to right, then right to left, then left to right. DFS would be hard for this one, but BFS would be easier. If not root, return so if root's empty, return this. Otherwise, root exists and current layer equals root while while current layer, and then and the loop has next layer gen children of per layer to next layer. So for while cur so if it's true, do false. If it's false, do true. And that'll alternate each layer. And so if next layer has nothing, then we don't append anything. So if next layer dot append so this will generate the next layer. So current layer sees root here, and I'm wondering, so if I so the very last iteration will have next layer empty updating this, but then the current layer would have the last layer. So I guess so my answer is gonna be list to append is gonna be reverse list Python. It's in place. So So if reverse is true, then I want to traverse the current layer in reverse order and then append the answer. And in our case, 3. Our answer would just have 3. And then the children will have 9, 20. And so in the next layer, we flip this and reverse is false. 9 and 20 will generate next layer 15, 7. And then so 9, 20 gives, so current layer is false, so then current layer in the very first iteration, reverse of 3, and then list.append gives us 3. This reverse goes to false because it was true to begin with, and then the current layer is now going to be 9 and 20, and the next layer is empty because current layer is 9, 20, next layer will be 15 and 7, and the list to append will be, because this is now true, 9 and 20. So 9, 20. So I think dot append would just give us this. Oh, okay, so false, whatever. 20 and 9, and then 15 and 7 is our next layer, and then we flip this reverse again. So current layer is 15 and 7. Next layer will have nothing, and list to append because reverse is now going from true, false, and then true due to this line of code. Then the current layer is 15, 7, and then we would have this. And then at the end, we would return the answer. I see, because the root was like this, I thought it was like a list. Oh, they want the values. Okay, so it's like a value object kind of like thing. So, hopefully this can handle that situation. This just because this handles the direction, and then this handles the value, and yeah, might be a bit slow. All right. Yeah, I mean that's all I had time for. That's it for this one. Really need to pee. Chat soon. Bye.